Hello and welcome. It's that time of the year again where we start revising for O-levels, A Maths. So for those of you who are taking the A Maths paper this year, I'll be going through the Anderson 2021 Prelim paper. Why Anderson? Because it's the alphabetical order. It's the first paper I could find online. If you'd like me to cover other papers, do let me know. Without further ado, let's do question 1 from paper 1. A curve is such that the second derivative, d squared y dx squared, is equals to 2 multiplied into 1 minus 2x. And the next clue given to you is the equation of the normal to the curve at the point -1, is 9y equals to x plus 64. So that is the equation of a straight line. 9y equals to x plus 64. Let me change to orange and underline this. Right, and find the equation of the curve. So conceptually, you need to kind of know this in your head. If you have a building, I'm going to imagine the building. So this is the ground. This building has 3 floors. You can think of it as, the equation of your curve is y equals to something, some function in x, right? And then the first derivative, if you differentiate once, it's 1 level down, it's dy dx. If you differentiate another time, you get d squared y dx squared, right? And what we are given in this question is this. We are given this, so we integrate once, integrate twice to get back the equation of the curve. Y equals to some function in x. And as you know, the difficulty in integrating is that we get a constant of integration. So we'll look to solve that with some clues provided by the question. So let's first do the first level of integration. Let's get from the second derivative up 1 level to the first derivative. Let's integrate second derivative with respect to x. And that is the same as integrating this with respect to x. And you know what? I'm not going to integrate in this form. I'm actually going to multiply it out. I'm going to expand out. So that's 2 minus 4x. This is a lot easier to integrate for me. All right. So on the left hand side, this becomes dy dx. On the right hand side, we're going to get 2x minus 2x squared plus c. So this c is the problem because I have no idea what c is. But there are some clues in the questions which can help me, solve for c. So it just so happens that at the point -1, which means when x equals to -1, y equals to 7, or when x equals to -1, the normal to the curve at that point is equals to this. Now, I kind of know that the normal is perpendicular to the tangent. And you know that the relationship of perpendicular lines is such that the gradient of this line and the gradient of the other line multiplied together is -1. So I can say that at x equals to -1, the gradient of the normal is equals to 1/9. Right? How did I get 1/9? And that is from this straight line equation. Okay, why is it 1/9? Now you recall that the standard form of straight line equations is y equals to mx plus c. And over here we have 9y. I need it to be just y without the 9. So I'm going to divide by 9 throughout. So I get 1/9x plus 64/9. Right? But I don't really need to know about that. I just want to know what is the thing in front of x, and that's 1/9. That is the gradient of the normal. Okay, if the gradient of the normal is 1/9, that means the gradient of the tangent should be -9. Yeah, why is it -9? Because -9 times 1/9 will give me -1. Right? The gradients of 2 perpendicular lines multiplied together will always be -1. So, and the gradient of the tangent at that point means that at x equals to 1, okay, so let's summarize this information over here. So with this, I can say that, hey, at x equals to -1, dy dx has the same gradient as the tangent of the curve, right? And that is -9. So using this, I'm going to substitute inside here to solve for c, which means that -9 is equals to 2 times of -1 minus 2 times of -1 squared plus c. Okay, and that should give you, let me see, I worked this out previously. So c is equals to -5. Great. So that means dy dx is equals to 2x minus 2x squared minus 5. Okay, so this is where we are now. In terms of the building, we are here now. We're going to do one last integration to get y. So let's do it. I'm going to integrate dy dx with respect to x. That's the same as integrating this one with respect to x. On the left hand side, I'm going to get y. On the right hand side, I'm going to get x squared minus 2x cubed over 3 minus 5x plus another constant, which I'm going to call c1. Now be careful, don't call this c. If you call this c, then you're saying that this term over here is negative 5. It's not, right? It's some other thing. Okay, so how do we get c1? So we go back to the clue given over here. When x equals to negative 1, y equals to 7, right? As suggested by this pair of coordinates. So I can do that. Let's sub the coordinates into here. So I'm going to get 7 equals to negative 1 square minus 2 times of negative 1 cube 3 minus 5 times of negative 1 plus c1. Okay, and you'll get c1 is equals to 1 over 3. And therefore, we can finally write our full equation, y equals to x squared minus 2x cubed over 3 minus 5x plus 1 over 3. And that is the answer for question 1. Hope this helped, and I'll see you in question 2.